Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, we provide workshops and exercises to learn about AWS services. These workshops and exercises are published to our website aws-dojo.com. Amazon announces general availability of Amazon timestream sometime back, and I also gave one workshop as well as a video about how you can integrate Amazon timestream with AWS IoT platform. And some of my viewers ask about how can they write data inside Amazon timestream using programming like Python kind of language, because IoT is not the only source from where the time stream data comes or time series data comes. Sometimes they have to write edge programs and applications which can publish time stream data to databases like time series data to databases like timestream. So I thought I'll make a very quick video and exercise where you learn how you can write data to time series data to timestream. And I have chosen Python as a programming language, but the same method is applicable to any other programming language you choose for publishing the data. So let's get some understanding about time stream first, because that is more important, and programming part is a rather simpler part of the tutorial. So talking about Amazon timestream, it is a fully managed serverless database where you can publish your time series data. And when you talk about what is time series data, I will show a few examples, in fact. But time series data is, you can all say, you are capturing certain measurements, certain data in the context of time, and yeah, that kind of data is called time series. So for instance, I mean, typical example is when you go to the IoT world where there is some sensor which is capturing the, say, humidity or temperature or vibration or any other kind of measure, and it's sending time to time, temperature, this is time, this is temperature, this is time, this is the pressure, this is time. So time to time at certain frequency, it is sending data, it is sending the measurements. That kind of data is the time series data. Another example I can say is, suppose you're running some kind of compute instance, some kind of server, and time to time you want to measure memory consumption, CPU consumption. That is another example of time series data. If you go a little to the business world, then if you try to see the way share prices change. So with the share prices go up and down with time, and that's another example of time series data where you are tracking certain measurement against a frequency of time. So such data is called time series data, and time stream database is used to store such database. And why you store such data? Because then you want to run some kind of analytics, some kind of reporting, dashboarding application on top of this data to able to analyze your data, to able to view your data. So time stream, there are certain characteristic of time stream database which is important. First and most important, it is serverless and fully managed. That means you don't have to manage anything from the infrastructure point of view. AWS takes care of it. It has got data storage steering. So the way time stream has been configured, that it provides two tiers of data storage. And one tier is kind of a cache data. Well, not kind of cache, it's a cache data. One tier is a cache data where you keep the recent data so that your queries are performant, and then other tier is where you keep data into a low cost storage, and that is more to keep your data from the compliance point of view, but you're not going to make any query on that data. So it does provide data tiering, and I'm going to data storage tiering, and I'm going to talk about that in the coming slide. And then next two important points, it has got built-in query engine as well as time series analytics, because the primary purpose of this data is to able to query data based on certain aggregations, and like you want to see the average of your measurements. You want to see the binning of your measurements and those kind of things, which requires a lot of inbuilt support for analytics and query, and the timestream database provides that as well. Okay, so it is a purpose built time series database. So moving on, let's understand some of the key concept of time stream database. Okay, and this will really help you understand how is data structure going to be, and once you understand that, publishing a data is not a big thing at all actually. So let's talk the first thing, measurement. So the measurement or measure is the most fundamental unit of most fundamental thing of a time series data, because you're always talking about measuring something, whether it is shares price or it is CPU utilization, memory utilization, to vibration of a sensor, to temperature of a sensor. The most fundamental thing is that you are measuring something. You want a time series data because you want to measure something against the time. So the measurement is the most fundamental thing. And Amazon time stream gives you flexibility to literally define any level of measurement you want. There's no fixed schema here, so you can say, yeah, I mean, you can just like any key value pair, you can go and define your you can create your measurements here. And whenever you're talking about measurement, one thing comes always along with that, especially in time series database, and that is timestamp. A measurement is useless in a time stream database if there is no time attached to it. So measurement always comes with a timestamp. So your CPU against a time, your CPU utilization against a time, your memory consumption against a time, your share price against a time, your temperature against a time. Okay, so your measurements, again, you can send as many as key value pairs of measurements, but each of those measurements will come with own time when that measurement was taken. So measurement and timestamps are two must-have things together, which create the most fundamental part of time series data. Now comes next part, dimension. So we did the measurement, but we did the measurement for what? So let's take example. So for instance, okay, share prices. So share prices, but for which share, which company share? CPU utilization or memory utilization, but which server we are talking. What is server name? Which data center the server is located? Which country the server is located? Yeah, which things like that. Similarly, like for instance, like we talk about again coming back to this SharePoint price. The SharePoint price, okay, but in which can we talk about some registered exchange where this, in which context we are talking this price here? Similarly, if you're talking about again some sensor measurements like temperature or pressure, so which sensor, which machine the sensor is deployed, which factory the sensor is in, which plant the sensor is in, which country it is, which state it is. So dimensions are, these things are dimensions. So you're doing a measurement, but measurement against measurements in the context of what? So dimensions provide metadata about the measurement. So you can come to know, so when you say I'm getting a temperature, then your dimension could be which sensor, which plant, which factory, which site, which state, which country, things like that. Measurement of a CPU, then which server, what type of operating system on top of that, which data center, which country, things like that. So Again, you can define as many dimensions as you want. And basically, dimensions are important because generally, like dimensions are used in your reporting purposes. So you might want to see that what is the average temperature of, what is the average CPU utilization of Windows Server versus Linux Server. Then your operating system has to be one of dimension. Then only you can say, okay, let me query my average CPU utilization in Windows Server versus Linux servers. Yeah. So when you are capturing a time series data, always keep in mind that you need to think through based on your requirement of the reporting, your query, the dashboarding you want to do with this time series data. You have to capture the dimension. So you have to attach a metadata with your measurements, and this metadata then is used in your query, in your reporting, to be able to see the measurement in the context of certain dimensions, certain business. Yeah, then it makes sense. I mean, average temperature is nothing unless you want to see the average temperature of my sensors across machine. Yeah, and then it gives a business meaning. Otherwise, average temperature itself is nothing. It gives you no business meaning. Okay, so that's called dimension. So these three things, dimension, timestamp, and measure, are the three most fundamental thing of your time stream database. Then comes your record, and to be honest, record is the simplest part. So when you put this dimension, measurement, time string together, it is called one record. Again, different records can have a different set of dimension, measurement, and timestamp. Fairly okay. So we might say pressure 40 in factory 1 sensor 1 is one record, but there could be a pressure 40 sensor 1 factory 1 site 2 could be another record. So record to record, your dimensions, your measurements, of course your timestamp can change, but one record consists of dimension, measurement, and timestamp. And then you put all these records together. So now you need to organize these records together. So related records you put together, and this related records becomes part of one table. So you can say that now, of course, you probably don't want to create a table in such a way that in your table, one row talking about, say, temperature of your sensor in a factory, at certain machine, and next record talking about share price of a certain company share. Right? These two are somehow not related. Yeah. Table is a way you can organize related records. So you can create multiple tables in time stream and say in one table I keep one type of measurements. Generally, you keep those kind of measurements together in one table, which you want to see together in terms of when you try to create some aggregated query, average, union, group by, binning, those kind of things. Then you want to keep such records together into one table. So table is a way to organize your record. And then you have concept of database. Database is a way to organize your multiple tables. So if you think that, hey, your company is quite big, where you get a number of different tables, and you want to control your access, your organization at the table level, then you can create multiple databases. Each databases can have their own set of tables. Tables can have their own set of related records. So this is the most fundamental thing, guys. I mean, if you understand this one, the rest is all simple part. Okay. So Having gone through the key concept, let's go through some other points. So how does the sample data look like? Look at this sample data, and let's try to understand this whole concept we just went through in the context of that. So these two columns you see here is called measurement. So you can see here, your measurement is really a key value. So it's saying your measurement is disk utilization, CPU utilization, memory utilization, swap utilization. Again comes to disk utilization, and these are the values. So you can really have measurements. It's like key value. It's like NoSQL kind of data, right? So there's no fixed schema here. Just keep that in mind. And in this case, you can have your measurements here. These are the values of the measurements. And then you also provide a timestamp. So measurement has to come with a timestamp. Otherwise, it is nothing. It has no meaning in time series database. And then these are the dimensions. Like for instance, this one saying is this is a disk utilization. This is the value. The host name is this, which is in the London city, and this is the country. Now, in this example, like city, host, and country are 3 dimensions, but you could have put like this is my rack, this is my data center. Those could also be a dimension here. But like in this case, for instance, the user wants to have a query based on the host, city, and country. So they kept these 3 as a dimension. But if you want to keep data, keep query based on say operating systems, your rack, your data center itself. Your machine make, could be anything. All those things can also be added as a dimension here. So this is how your dimension, your measurements, your time look like in your table. Okay, so let's move on. So let's come back to this storage tiering thing. So as I mentioned, that time series data is a data which is. But only the way the time stream has been defined is that it has been defined to make a very fast query and point in time query on your data, and in order to do so, actually the whole storage is actually broken down into 2 types of storage: in-memory storage and magnetic storage. And when the data comes, it always comes to in-memory store. And this is where in-memory store, where it's like a cached memory, where you say you make your queries, and you really want to make query, get a fast calculation back, and that's why it is a memory store. Okay, it's a fast storage. But you don't want to keep your data always in the memory store. You do have a choice to keep that, but then you are increasing your cost, because you say, you know what, I make my query, but since it is a time series database, this query become like I just want say first 6 months of data, or 1 day of data, or 1 year of data, things like that. So you can actually decide that how long you want to keep your data in the memory store, and after that you want to move it to the magnetic store, which is a low cost storage. And when it goes to magnetic store, you don't query data from there. So you query data only from the memory store, but it is in the magnetic store for the compliance purposes. So when you are designing your time stream database, you have to provide 2 configurations. One is how long you want to keep your data into memory store, and how long you want to keep your data into magnetic store. And then when data comes in, based on your configuration, for that time the data will stay into your memory store, and then after that it will automatically move on to magnetic store. And based on how long you want to keep data inside magnetic store, you can then remove data from your magnetic store as well. Okay, so you can do data tiering like that, and the whole purpose of data tiering is to keep the latest data based on your requirement to memory store, so that when you create your reports and dashboard, they run pretty fast, because the time series data is literally like a high number. I mean, think of a sensor which is probably sending 1 measurement every second, or 1 measurement every 5 seconds. think of a data it will accumulate, right? So you really don't want to keep that whole data at one place. And then second, when you create report on such data, then you also know that as the data becomes old, stale, it is not useful anymore. And that's why this two tiers concept helps, where you can say that I can keep latest of my data into memory store based on my requirement. It could be 6 months to 6 years, and otherwise I move it to magnetic store, or even remove from the magnetic store after some time. And all this retention periods you can define for both type of storage, and based on that, data is automatically managed. So this is another very important thing which you should consider into your design, into your requirement gathering when you're designing a time stream database. So moving on. So once the data is in the time stream, actually you can query data in many ways. You can query data using Amazon SageMaker. If you want to use it for machine learning purposes, you can use it with the quick site, where you can do the reporting and dashboarding or real-time analytics on the data in AWS. You can also use reporting and dashboarding tools like Grafana, or you can also use some JDBC connector to connect to that. To be honest, you can also write code to fetch data from time stream database, but I'm not going into the code part, because generally the purpose is that when you bring this data inside time stream database, then you might want to use some sort of reporting tool to work with time stream to capture the data, to view the data and do different types of analytics you want to perform on it. Okay, so these are few methods you can use to consume the data. Then what it takes, so today I'm trying to, having explained the core concept of time stream database, I want to talk about how you can write code to time stream database. And that's the second part of my presentation, and that you also do in the lab later today in this workshop, in this exercise, I mean. So what you do, and I'm taking Python as an example, that first you go and use this timestream-write. You create a client for the timestream-write. If you want to query data, then you use timestream query, but query part, again, I'm not using today, because it's very rare use case that you might want to query data through the code, because generally you want to use some reporting tool to talk to time stream database. You don't want to query, but technically you can query data as well from time stream database. But in that case, you have to use a different client, that is timestream-query. In this case, you're using timestream-write because you want to write data to this database. And then first thing you define your dimension. Okay, so coming back to same key concept, you have to define your dimension. And as I mentioned earlier, dimension is also like a key value pair. So here you can see that in this example, I'm saying that my one dimension is plant, this is the value. Another dimension is machine ID, this is the value. Sensor type, this is the value. Device ID, this is the value. Now you can create as many dimension values as you want here, but you configure your dimension, okay, in your code. Then you write your record or your row, and when you write your record, actually, of course, record is all about measurements. Okay, so you can put your measurement. So you can see here it's saying that, okay, my measurement name is vibration, and my measurement value is 23.5. And this is my value type. You provide a data type. So this way you can provide as many measurements as you want. Again, measurement is also like a key value. Only thing is that you also need to provide data type with your value. Okay, but you can have as many measurements as you want. But then when you put a measurement, it has to be associated with two more things. One is you say, okay, I'm taking this measurement, but what is the metadata for this measurement? And that is your dimension. You have to mention your dimension against which this measurement has been taken, and what time this measurement has been taken. So when you create a record, again, you can see a record is a combination of your timestamp, your dimension, and your measurements. And your measurements could be as many key value pair you want to keep it here. And then you can create a record like that. And actually you can create an array of records. So if I'm like, of course you can take one record and you can write it, then that of course you can do. But since time stream database is generated in a very high frequency, it is recommended that you might want to do some batching of your time stream database and then send that batched records in one go. And you can create a batch like this. Like in this case, I'm creating two records, like record 1 and record 2, and putting into an array. Okay, so you can do batching of your records, and of course you do have a choice to send record by record, but you don't want to probably do that, keeping performance in mind. So you might want to do some kind of edge based batching, and then you send the record, and then voila, after that it is pretty straightforward. You say I'm going to write my records, and this is my database. So this is a time stream database. This is the table, time stream table. And then these are my records. And again, yeah, and then it will simply go and write your record. So this is how you write code to time stream. Actually, you create a client, you define your dimension, you create your records, you put all your records into a batch like an array of records, and you simply write the records. Yeah, so that's how the code works to write data to time stream database. So moving on, so what are you building today? What you're building is pretty straightforward, guys. Actually, it's, probably one of the simple exercises you can finish in hardly 5-10 minutes. Is that we are going to actually create a time stream database and table, and then we'll use this time stream API in Python code to write data to time stream table. Yeah, that's what we are going to do today. So in order to do this exercise, we have published a exercise to a website at aws-dojo.com, and this exercise provide step-by-step instructions to perform the job. I have provided the URL of this exercise in the description box below. So I'm going to show you the steps of the exercise, and post that you can click on this link and you can complete this exercise at your own pace, in your own comfort. Okay, so let's jump onto the exercise. So here is the exercise, and these are the steps you have to perform to get the job done. The step 1 is pretty straightforward. It says that you need to have an AWS account, and if you don't have any AWS account, then you might want to use this link to create one trial account. Then we create a time stream database. So we log into AWS Management Console. We go to the Ireland region. We selected the Ireland region in this case, and then we say we want to create a database. And then it says, okay, fine, standard database. This is Dojo database is the name of the database. So once database has been created, then we say we want to create a table, and this is my database created. We simply click on the create table, and then it says that, okay, tell me what is the table name. So you say Dojo table name, and then here you provide your data tiering configurations. You are saying that my memory store retention, I'm saying 1 day here, so keep my data in the memory store for 1 day and then move to magnetic store, and I'm keeping my magnetic store retention period as 1 day as well. That means keep my data in magnetic store for 1 day, and after that you simply remove it. And if you look at here, this value could be as minimum as 1 hour and can go up to 12 months. That means you can keep 1 hour to 12 months of data into memory store for the reporting purposes. And after that, you can move it to magnetic store, where the data could be as minimum as 1 day and can go up to 200 years. So you can keep your data into magnetic stores for up to 200 years, okay, for the compliance purposes. And with this configuration, we simply go and create the table, and table is created in no time. Again, you see that it is completely serverless. It did not ask you the machine size or performance requirements. Say, okay, tell me your table name, tell me your data tiering configuration, and we will take care of everything. AWS will take care of everything behind the scene. Now that your database and table has been created, we create a Cloud9 environment, and we use Cloud9 environment to actually do the Python programming. So we go to the Cloud9 console, and then we say we want to create a new environment. We give Dojo environment as a name. Then we selected T2 Micro as an instance type, Ubuntu as an operating system, and say we want to create the environment. And it will create a Cloud9 environment for my programming purposes here. Now we need to configure a few things here before it is, it can work with the timestream database APIs. So first thing, we'll go and update the environment and resources here. Then we check the Python version. And then after that, we install Python Boto 3. So we're installing Python Boto 3 SDK so that we can do programming with Amazon timestream database. Yeah, we do install Python Boto 3. It will install the Python Boto 3, and it is always recommended to upgrade your Boto core and Boto 3 so that it takes the latest of the APIs and it refreshes the APIs as well as the code. So you do this Boto core upgrade first, and then you do Boto 3 upgrade next, and then this will take care of upgrading your Boto 3 and Boto core. And with this, actually, your environment is up and running. Now you have got Boto 3 SDK deployed on your Cloud9 environment, and it has been upgraded, and you can now do programming with timestream database. So what we did in this case, now that we created a dozo client.python file. Okay, so we created a simple Python file, and here is the code of the Python file. And as I explained earlier, it's the same way. So yeah, here is my database name, dozo database, my table name, and then I just captured the today, like latest time, so like time of the now. And after that, I created a client for timestream-write. And then here I'm defining two dimensions, like in this sample here. So you can see here one dimension has plant, machine ID, sensor type, and device ID. And other one has got only plant, sensor type, and device ID. So again, you can have multiple dimensions per records. And then I created two records as well. And one record says that, okay, here is my current time, which I took from here. These are my dimension 1 and dimension 2. And then one is doing a measurement saying I'm capturing vibration, which is of double type, and here is the value. And other measurement saying, hey, I'm capturing a humidity. And humidity is again a begin type, and value, this is the value. So again, you can define as many records as possible as you want. Each record has a measurement, and you can define as many measurement as you want, because yeah, it's just key value and type pair, nothing more than that. So we created two records over here, and after that we simply create an array of this record. So again, you can update your records individually, or you can create batch of the records. In this case, I created batch of the record, and I simply call this write records method, and it will simply write my record. So again, this is one example of the code. You can change it the way you want, based on your own requirement. And after that, you simply run this dozo client Python file, and you can see that it has successfully completed with the HTTP status goes back as 200. Okay, so now my code has run, and it has created my data inside timestream database. So what you can do is that you can go back to your timestream console, open the table, dozo table, and you can say I want to query the table. And when you query a table, you can actually do a SQL query like this, where you can say I want to select all the records from dozo database, dozo table. So like a normal SQL query you can make the SQL query, and it will start showing you the records. You can see here it's showing you two records we created earlier, and you can see how it has put your dimensions and your measurements together with a timestamp. Okay, so you can see that it has complete flexibility. For each record, you can change your measurement, your dimension, and it is pretty flexible. Since it has no fixed schema, it is pretty flexible to capture each your record by record changes and measurements and dimension, and then voila, you have this whole related data together in one records together into one table, which you can use for query and reporting purposes. some other things you can see. So this is one way. So you can see that this is how your data look like. Then you also can see the schema. So if you go to the Dojo table and say, I want to see the schema, it also shows you the schema. So it shows you that, okay, this is how the schema look like. So it's saying that you do have a time, then you have some measurement name, measurement value, and there are two values here because it's showing that it says that there are two measurements. One is double type, one is begin type. Okay, and these will hold their values. This will hold the measurement name, and these are the 4 dimensions you have configured. Okay, these are the 4 dimensions. It shows you, timestamp, measurement name, measurement value, and dimensions. It shows you the schema. So suppose you get to see some existing time stream database, you can always see the schema and identify the various dimensions and measurements over there. You can also see that in the context of measures. So for instance, if you want to see, okay, can I see my measurements and dimension together in my schema? You can do that as well, because here it does not give any idea that this measurement has what dimension, this measurement has what dimension. You don't know that. And that you can see if you click on this show measures options here, or tab here. And when you click on that, it shows you these are my measurements, humidity and my vibration. These are the data types, and these are associated with these dimensions. So it gives you idea about, and especially if you're trying to create a report and you want to make use of reporting on the measurements, you need to understand that what are dimension associated with your measurements. Unless you know that, it will be very hard, and that information doesn't come out from here. So here you can see that how your measurements are put together in context of dimension, and you can use this information for the reporting purpose. So that was all, and that's where the exercise finishes. Next step is to go and clean up the resources, and you're good with that. So hope you like this exercise, and if you like, please click on the like button and please subscribe to my channel. We try to provide 1 or 2 such videos almost every week, and there are many other such workshops and exercises which you can use to learn about AWS services. Please feel free to visit our website aws-dojo.com and use those exercises to learn about AWS services. We always look forward to your feedback, and if you have any feedback, you can provide either in the YouTube comment section, or you can also reach out to this Contact Us tab, and there you can provide us feedback. And we always look forward to your feedback to improve our content, to provide new content. So that was all for today, guys. Thank you very much for your time. Stay safe and see you again in a while. Bye-bye.